Today. There's a notes page on Google Classroom that we used, and we'll definitely want a calculator. So quadratics ends up being our second type of function that we've studied this year. We've studied linear. We're currently on quadratics. And we're going to finish up the year with exponentials. What's cool about any function in the mathematical world is they all have a similar structure to them. And we can use that to kind of exploit and make graphing a little bit easier. Now, linear, we had a really nice way to graph it, our slope-intercept form. I'm going to rewrite this to be more within the conventions, ax plus b, so y equals ax plus b. M, or in this case A, controlled the slope, also known as the steepness of our graph. Our very last number on this term here, plus B, controlled the y-intercept. Excuse me. So what's cool is this y-intercept, or the height. Quadratics, in their standard form, ax squared plus bx plus c, follow a similar kind of motion. Hold on, I need to grab a Kleenex. Sorry about that. A also controls the steepness. Because it's a quadratic, we do not have a constant slope. So where linear, we have this perfectly constant sloped line. Quadratics, that slope ends up changing at every given point. So it's steeper here than it is at the bottom, and then it gets steeper on the other side. So it's decreasing in steepness and then increasing in steepness. Our number on the end, this plus c has nothing, is also y-intercept. It also controls the height of our function. So the higher this number, the taller up our parabola is. So if it's a plus 5, it's up here. Minus 5, it's down here. It gets moved just like this line, plus 5, minus 5. B is a new addition, which causes the graph 1 to change shape, so no longer is it a line, it's a U. But with the addition of B, this controls the vertex, but it's not perfect. So if I have a number for B, that controls it to the left, to the right, it moves it up and down a little bit, but this motion's not 100% perfect. It's not 1-to-1, so if this is like a 3, it doesn't mean it moves at 3. And then exponentials, we haven't studied those yet. I just want to throw it in there. Their standard form is a bx minus h plus k. And the only similar letter is a, still controls that steepness. Still controls steepness. Bigger the number a is, the steeper our exponential graph. And an exponential graph looks like this. And it just takes off. All right. So parabolas. Some of the important pieces of parabolas. These two dots right here are known as our roots. They are the most important feature of a parabola. They're the x-intercepts. They're where our answers typically are. We have this point all the way at the bottom of our parabola. It's known as the vertex. That vertex is the smallest or the largest, depending on the graph, that the parabola will ever reach. So that's the lowest point and turns around and goes back up. On this graph, it's a maximum. It reaches its highest point, then goes back down. We also have the y-intercept, but it's not as important. so we don't care. So these are our three most important parts: roots and the vertex. Some cool parts about parabola: if I draw a straight line through our vertex, that is the axis of symmetry. The axis of symmetry. A parabola is perfectly symmetrical along that line. So dots on either side are exactly the same distance from the line as on the others. 1.5, 1.5, 2.5, 2.5, 1/2, 1/2, just because we're halfway. If they were perfectly on a grid point, you could count actual boxes, even could still be decimals. But it's that same exact distance on either side of our line. And that's what's going to help us graph this. So we're going to graph the long way. This is our mama function. It's the most generic exponential function. We're just going to plug numbers in and we're going to plot it. Let's start with the easy numbers, 0, 1, and 2. So if I plug in 0 into my function, I get 0 squared, 0. Our first dot's right there. F of 1. We plug in 1, we square it, we get 1. That's cool. Plug in 2, we get 2 squared, we get 4. So there's half of our parabola right there. Let's plug in -1 and -2. If it's truly symmetrical, we should find 1 and 4. So here's some good practice with squaring negative numbers. That was a giant 2. Don't know why I have the giant 2. -1 squared, 1. Should be -1, I apologize. -2. -2 squared, 4. If I plot those, they end up right here. I get the other half of my parabola. Here is where we can see that axis of symmetry and our symmetrical points. 2 spaces, 2 spaces. 1 space, 1 space. So to graph a parabola, we're really only going to focus in on one side and then duplicate the other side around the axis of symmetry. But I don't want to have to do this the long way. So if I have a different quadratic, I don't want to have to plug in 0, 1, 2, 3, 4 every single time, because 0, 1, and 2, they might not be the numbers we want to use. If I have my parabola and it's way over here, plugging in 0 could be a very, very large number that I can't even plot. So how we're going to approach it is by finding that axis of symmetry first. Finding the axis of symmetry requires a formula: x equals -b all over 2a. We get the b and a from when it's in our standard form. Vertex, we then plug that number into our function and we solve to get it, and what we end up getting is a coordinate point where our axis of symmetry is here, and we get whatever that number is when we plug it into our function. So we're going to try it with this one. We're going to go the long way, and then I'm going to show you and talk about the cheater's method on every one of the problems. So let's start off by doing it the long way. That way, if the cheater's method doesn't make 100% sense or you don't remember it, you can still have a way to solve it. So we're going to find the axis of symmetry. X is equal to -b all over 2a. -b, so it's -6, all over 2 times 1, which is a. We're going to put the two negatives together. We get plus. 2 times 1 is 2. So we really get 6 over 2. So our axis of symmetry is 3. So there's our axis of symmetry. So what that's telling us is somewhere on this axis of symmetry is our parabola. Maybe it's way up here, maybe it's way down there, somewhere right here. It's not over here, not over there. Somewhere on this line we have our parabola. So now we're going to go see if we can find it. We're going to find the vertex. So we're going to take our function and we're going to plug in our axis of symmetry. X is 3, so we're going to plug in 3 everywhere we see x. 3 squared is 9, negative 6 times 3 is negative 18, plus 5. 9 minus 18, that's negative 9. Negative 9 plus 5 gives us negative 4. So our vertex, we're going to put in the middle of our table, 3, negative 4. So there's our vertex right there. So now we have to just, well, we're going to find the rest of our points, but we're going to get something going in our brain. That way we know if we're graphing it correctly. Our parabola can either open up or it could be opening down. That all depends on this number right here. Positive is up, negative is down. So it's positive. We expect our parabola to do something like this. Let's confirm it by plugging in some numbers. To fill out the rest of the table, we only have to do half. So we have 2 and 1, 4 and 5. We're either going to plug in the 1 and the 2, or we plug in 4 and the 5, because we know that these answers are symmetrical. Best choice is to do the 1 and the 2. The numbers are smaller. So we're going to plug in 2 into our function. So 2 squared minus 6 times 2 plus 5. 2 squared is 4. Minus 12 plus 5. So 4 minus 12 is negative 8. Negative 8 plus 5 is negative 3. So we get those two numbers for free. We're going to do it again, but this time we're going to plug in 1. 1 squared minus 6 times 1 plus 5. That's 1 minus 6 plus 5. That is 0. It takes 5 points to accurately graph a parabola. There's our 5. 3, negative 4. 4, negative 3. 5, 0. We also have negative 2, 3. 1, 0. We can see those symmetrical dots on either side of our axis of symmetry. 2 squares, 1 square. The hardest part about drawing a parabola is making it a U rather than a V. They're U-shaped, so give it a little bit of a curve here at the bottom. Wow, not my greatest left-hand side of a parabola there. Much better. And there is the parabola. So let's talk about the cheater's method to get our points in our table just a little bit quicker. I only call it the cheater's method because it gets us the numbers a whole lot faster than having to plug in and solve our functions. And you guys didn't discover the knowledge for yourselves. I am teaching it to you. It's also just fun to call it the cheater's method. It makes you guys really want to use it. Okay. How the cheater's method works is it follows a principle of what happens with square numbers. So if I have 0, 1, 2, 3, 4, and 5, 6, whatever, and I square each of these. So 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, yada yada. So I get 0, 1, 4, 9, 16, 25, 36, so on and so forth. The pattern between these squareds actually happens to be the odd numbers in order. And this will continue. The next one's 49. That's 13. Because every quadratic has a squared, and that's the biggest power, these points follow a similar setup. So on this problem, you start with your vertex, so your middle point right here, and the jumps from your vertex to the next point follow that pattern of squares. But there's a little bit of a catch, and this is where if you're not paying attention and you're not using it fully, you will get it wrong. So you want to be careful. So I'm going to erase this just so I have some more space. That is the beginning part of the pattern. 1, 3, 5. But, like we talked about earlier, A controls your steepness. So we're going to take this pattern and we're going to multiply it by whatever the value of A happens to be. For this first simple problem, A is just 1. And since A is 1, this pattern remains its exact self. And we can see that happening. From -4 to -3, that increased 1. From -3 to 0, that increased 3. The next one, if we were to try it, would be 5. So this side would be 5. You can check it if you want. Plug in 0. That goes away, we're left with 5. So that's how the cheater's method works. We take this initial pattern, we multiply it by our A value, and our points get to move by this new system over here. So let's try it where A is negative. You have to find the axis of symmetry in the way that I've shown you. You have to use -b over 2a. So negative b is -4 all over 2 times -1. So we get -4 over -2. So our axis of symmetry is 2. So there's our axis of symmetry. We're going to plug in to find our vertex. Negative. That negative is not included with the 2. So 2 squared is 4, so we have -4 plus 8 minus 3. -4 plus 8 is -4. It's not -4, it's +4. +4 minus 3 gives us 1. So our vertex is right here. Now I'm going to erase this so I have some space to work. Because our A value is -1, I know that this parabola should be opening down. Numbers I can pick 0 and 1. I'm allowed to pick 3 and 4. 0 and 1 is a whole lot easier than 3 and 4, so we're going to do that. So f of 0 gives us -0 squared plus 4 times 0 minus 3. So that's really 0 plus 0 minus 3. So that's -3. Then we're going to plug in 1. We get negative, then 1 squared plus 4 times 1 minus 3. So that's -1. So 1 squared is 1 with the negative. Plus 4 minus 3. That's 0. The rest of the table is identical on either side. And let's just confirm this with the cheater's method. Okay? So the cheater's method, oh, that's kind of cool. I don't want the 3 included though. Can I just move it without it? Dang it. Okay, hold on. Just rewrite this real quick. -3. So the initial pattern, starting from our vertex, the first jump should be 1, second jump should be 3, should be 1, should be 3, but we're going to multiply by our A value, so in this case -1, And this number over here is actually the number of how it's moving. So this is -3, -1, -1, -3. Well, check it out. 1 minus 1, 0. 3 minus 3, -3. Works. Plot our points. 1, 0, so here. 0, -3. You can get your symmetrical points on the graph or from the table. Not my best problem, but there it is. Opens down. Let's use our cheaters method fully on this one. We don't get any way to get the axis of symmetry faster, so we're going to take -b all over 2a. So we get -12 all over 2 times 2, so -12 over 4. Axis of symmetry, -3. Goes in the center of our table. Plug it in. Whoops. As I say, plug it in, and then I don't plug it in promptly afterwards. Carlisle's a genius. -3 squared, that's 9. 2 times 9 gives us 18. 12 times -3, that's -36. Plus 10. So that gives us -18 plus 10, and we get -8. 1, 2, 3, 4, 5, 6, 7, 8, right there. Really hope this parabola opens up, otherwise this is going to be a really, really stupid graph. Lucky for us, it does. So our parabola, we expect it to do this. In our table, we have -4, we have -5, -2, -1. So the cheaters method tells us that we're supposed to go by 1 and by 3, and then 1, and then by 3. A is 2, so we're going to multiply all of these by 2. And so really that's 6, that's 2, and that's 6. All right. -8 plus 2, -6. -8 plus 2, -6. -6 plus 6, 0. -6 plus 6, 0. Let's confirm that that worked by plugging in this one and just seeing what we get. So f of -1 is 2, -1 squared, plus 12 times -1 plus 10. -1 squared is 1. 1 times 2 is 2. 2 plus, or that is -12 in the middle, plus 10. 2 minus 12, -10. -10 plus 10, 0, exactly what we see. So we don't have to plug in our points. We have it over here in our table. So we've got -2, 6, 1, 2, 3, 4, 5, 6, and then -1, 0. Identical points on the other side. We draw a U, not a V. Man, that left side for me is just all sorts of bonkers. And there we go. There's our problem. Not my best picture because it should be symmetrical. Like the right side I could just kill. That was pretty good. This left-hand side, man, I just struggle lesson. All right, last one. All right, axis of symmetry. X equals -b all over 2a. So we get -18 all over -6. Axis of symmetry is once again at 3. Find our vertex. F of 3 equals -3 times 3 squared plus 18 times 3 minus 24. So that 3 squared, 9. 9 times -2, or 9 times 3 is negative 27. Middle, we get 18 times 3, that's 54. Minus 24, so we add all that together. We get 27, we get 3. So there's our vertex. Just want to double check on my end. Yep, okay. Sometimes you just don't trust yourself. All right, pattern should be 1 and then 3. On this side should be 1 and then 3. So we have 2 and 1, 4 and 5. We're going to multiply this by negative 3. That's our A value. So really negative 9, negative 3, negative 3, negative 9. So from 3 minus 3 is 0. 0 minus 9, negative 9. Plot those points. So 3, 3, 3, 2, 0, 5, negative, or 1, negative 9, 5, negative 9. So it's just off the graph that I have on my page, but it's going to be right there. Again, looks like it should just be a V, but it's definitely a U. It's curving. And there's our problem. What's funny is if you keep going with this pattern, this should be 5. So it's really minus 15. So at 0, it's negative 24. What's funny is that's exactly the number we see right there for our y-intercept.